All right, it is time for 11-2, day 2, a little one-sided limit action. Pretty exciting. And my dog is eating dinner, so you'll probably hear her making a lot of dog chewing sounds in the background. I'm going to be using my little piece of paper to cover up one side. It says, I think you are very appealing. Get it? Because it's a banana. I mean, it's no bumblebee, but it's pretty cute. Okay, so I have been, hopefully you have been, studying limits and learning how to tell on a graph what the limit is, meaning what does the graph approach when you go towards the x value that they're talking about. So we've been looking at things that were notated like the limit as x goes to whatever the number is going to be. And we would look and say, so for example, this is the y-axis on this one. So this is 3. If we were doing the limit as x approaches 3, we would have come down from the left side and said, oh, it's going towards a y value of 1. How about from the right side? It's going down towards a y value of 1. So you'd be coming in from both sides and saying, as you get close to this x value of 3, what does the graph go towards? The graph goes towards 1. So I would have said the limit of this function as x approaches 3 is 1 because the left-hand limit equaled 1 and that was equal to the right-hand limit. And so that's what we've been doing. And then if they don't come towards the same value, the limit doesn't exist. So for example, here from left, I'd be coming in towards a y value of 1, but from the right, I'm coming in towards a y value of -1. So the left side comes towards a +1 and the right side comes towards a negative. So they're not equal, so the limit wouldn't exist there. But one of the things you need to know in calculus is what's the one-sided limit, like if you're only coming at it from one direction. So in this case, the left has to equal the right, and then that will be your limit answer. What we're looking at is this notation. What if x is approaching a number and then there's a plus sign up high after the number? That is only asking what is happening from the right. So as you approach that x value from the right, what y value do you go towards? And then the other notation you're going to see is it'll say what's the limit as x approaches that number, and then there'll be a negative sign up after that. And that's asking you, what about from the left? So let's take a look at what that looks like in action here, and hopefully you can make some sense of this. This is not calculation based at all. It's completely an eyeball activity. You just look at the place they're talking about. Keep in mind your answers are always y values. So like this question has a 0 with a negative. So this is saying as you approach 0, which is the y-axis, from the left, what y value does the graph go towards? So at my little appealing paper, I'm going to put here because I don't care about what's happening on the right. I only care about what's happening as I approach from the left because it has a 0 with a negative sign. So if I go to the left of 0, meaning x equals 0, and I hop on the graph and I travel with the graph towards the x-axis or the y-axis, that goes down forever. And so the limit of the function as you approach 0 from the left side is negative infinity because it goes down forever. Okay, let's take a look at this next one. This says the limit as x approaches 8, and then there's a little teeny plus sign. So here I'm going to be coming at that from the right. So here's 8 on my graph over here. I'm only concerned about what's happening as I approach from the right. So I'm ignoring the parts of the graph that are to the left of that, and I hop on the graph to the right of it, and I travel towards the x value of 8, and I look to see what y value I'm going towards. It doesn't matter that there's not a y value right there. I'm going towards this y value of -1. So that's the right-hand limit, we call it in calculus. How about here? I'm going to be approaching 5 from the left. So there's 1, 2, 3, 4, 5. That's this dotted line. And if I'm approaching it from the left, I'm going to ignore everything to the right. So you go to the left of the 5, you hop on the graph, and then you approach the 5, but you stay on the graph and you ask yourself, what am I going towards? Well, you're going straight up, And so what you're going towards is going to be positive infinity, and you don't have to write a plus sign. So this one says limit as x approaches 3. That's it. So that's the one we did before. That's asking about both sides. So this is going to be, this one was from the left, this one's going to be both. So I have to check from the left and the right. As I come down from the left side, here's x equals 3. As I come down from the left side, I approach a y value of 1. Now I have to check from the right side of 3. If I get on the graph and then come towards that value of 3 for an x value, what y value does the graph approach? 1 again. So since the left equals the right, the value of the limit as this graph approaches 3 pinches in towards a y value of 1. All right, this is something new and kind of exciting. It's asking as x approaches infinity. So what that's really asking is what's happening over here as x goes off to the right forever. So when I look at the graph, the part that's going to go off to the right forever is this part. And these limit questions are always asking, what y value are you at? Well, if this is just going to go straight out forever, that is happening as I go back here to the y-axis at a y value of -1. This one's asking for me to go 0 from the right. So here's 0, cover up the left. And if I get on the graph that's to the right of 0 and I follow the graph, what am I approaching? Well, I'm going up. So that'll be positive infinity. Here it's asking me to look at 8, coming at it from the left, I think, since I can't see, but I'm pretty sure that's the left. So here's 8. I want to look at it coming from the left. So I get to the left of the 8. Oh, sorry, here's 8 over here. And I hop on the graph, and then I approach my 8 from the left side, and I look to see what y value am I going towards. Again, I don't care that the actual dot's down here. If you stay on this branch from the left, you're approaching this circle, which is happening at a y value of 1, because all my answers are y values. Here it says limit as x approaches 5. Doesn't say plus, doesn't say minus, so that means I'm going to be looking from both sides, and this is where x is 5, this dotted line, a vertical asymptote. So if I get on the right and the left of it and follow the graph, the left side is going up to infinity, and the right side is going up to infinity. So since they're in agreement, the left equals the right, then that will equal my limit. And so this would have to be positive infinity, indicating that everything is going up to infinity around 5. This part's just asking me to go towards 5 from the right only. So if I go towards 5 from the right, that's going up forever. So that's infinity. This one is asking me to go to negative infinity for x to go towards that. So x will go towards negative infinity as you go off to the left forever, just like going to positive infinity means you're going out to the right forever. So if you followed the very left end of this graph, you can see that it's getting closer and closer to the y-axis, but it's drawn in a way where you kind of see that that's supposed to be an asymptote. It's not going to cross it again. It's just going to keep getting closer. So this graph, as x goes towards negative infinity, is getting super close to this x-axis, and that has a y value of 0. So when we were talking about the right end of the equation over, where would it go? Here, the right end is approaching -1 as a y value, but the left end of the overall graph is approaching this, which is going to be a 0. How about as x approaches 0? There's no plus, no minus, so I'm just coming at 0 from both directions. So if I get to the left of 0 and hop on the graph, it's going to go down forever. So the left is going to be going to negative infinity. If I get on the right side of 0, hop on that graph and follow it, that's going up. So the right side is going to be positive infinity. So because this didn't say from the left or the right, it was looking for both the left and the right, and they're not equal. When the left does not equal the right side limit, then we say that the limit does not exist. You don't say 0, you just say that the limit doesn't exist. They don't have the same value. So this one does not exist. Grand finale. This one's asking me to approach 8, flat up, not left, not from the right, just go towards 8. Well, here's 8 right here. If I came from the left, I'd be dropping down to this value of 1. If I come towards 8 from the right piece of the graph, I'd be coming in towards a y value of -1. So again, because the left and the right are not equal to each other, this one does not exist either. So that's just learning how to look at the graph, which side to kind of come from and what you're looking for. Your answers are always y values. What are your y's going towards? This goes way back. This is domain. It's asking about the x. It's saying from left to right, what x's do I use? What x's don't I use? So you see that nothing touches here. So I have a vertical asymptote at 0 and at x equals 5. So basically, I can use all real numbers, but not 0 and not 5. So on a number line, you'd be looking at not 0, not 5, but everything else. And if you go back to fancy writing, we learned that as from -infinity to 0, not included. From 0 to 5, neither of those are included because you have to skip them. And then from 5 to infinity. So this is kind of the algebra 2 way to write our domain. This would be the calculus way to write your domain. So you maybe want to practice that to feel more confident if you're going to go on in math. So range refers to the y's, and so that refers to like the bottom up to the top. And we did this way back at the beginning of the year. So what we're doing in calculus, you should start to see a lot of things we did earlier in the year coming back saying, here's where you apply it. So if I started at the bottom, this goes from -infinity, and then this piece stops and goes over here. But the thing is, even though this is kind of weird and has an open circle, I still have a value there over here. And then even though there's a little gap on this piece, there's not a gap here. I have a value everywhere. Again, here's a dot, or excuse me, an open circle, but I have a dot there and there that kind of covered the gap. So then I keep going, and then these arrows go forever. So because this kind of jumps up and overlaps any spaces that would be taking place over here, this actually goes all the way from -infinity to infinity. There's graph everywhere I go. There's not a gap. Even though this looks like a gap, there's still graph over here. So back in algebra 2, we would have written that as all reals. Now in calculus, we would write that as -infinity to infinity. So now you should be all set. There's a few IXLs. You're going to do IXL E1, which practices day 1. E2, which practices this, what we're doing right now, 11.2, day 2. And then we're going to practice E3, which is overall limits. So whereas this one will just focus on coming from the left and right with the little baby plus and minus signs, this one will go back to the concept that the left and right have to equal each other. So you're aiming for a SMART score of 80. They'll go into the gradebook out of 8. Today is Monday. Hopefully you're watching this when it's assigned, and these aren't going to be due until Tuesday night. So you have plenty of time. They go pretty quickly. You're just looking at graphs and answering the questions. If you need any extra help, make sure you shoot me an email. You can watch Miss Miller's video or just kind of reach out for some extra help. Have a great day, afternoon, evening, night, whenever you're watching this. Bye, guys.